Good morning. Thank you very much. It's very nice to be here at AMA in Berlin. Yes, I'm going to talk about what is changing or has changed maybe some time ago in architecture and how we might think about what's really important to do in architecture work, whether or not you're called an architect. I can barely see you, it's very bright, but very quickly, who here has architect in their job title? The vast majority. Great. I quite often go to events and there's lots of people doing architecture not called architects, so that's why I ask. My name is Eoin Woods. I realise that's not obvious, even for people from the UK. Leave the E off the front. My first name is pronounced Eoin, like that. For the last 10 years, I've been chief engineer at a company called Endava, about 12,000 people in software engineering worldwide. And before that, I spent 10 years building products, some of which still exist, which is both frightening and also gratifying. And then I spent about 10 years building systems, to move money around in lots of very rapid and complicated ways. Let's just start with agility, given this is the Agile Meets Architecture conference. The point of Agile delivery is rapid and effective change. In a sense, nothing else matters. If we're doing Agile and we're not getting rapid and effective change, we're probably not doing Agile. Agreed? That's the point. And that's where Agile came from, because we wanted rapid and effective change. An old style, call them waterfall, whatever, old style methods weren't really delivering that. The problem with this, or maybe the opportunity, or maybe the threat, is that if Agile is aiming for continuous evolution for the system we're working on, that means when we start doing delivery, whether that's of maybe a big replatforming or a brand new system or reworking something, we don't know very much. Because after all, we embrace change, don't we? So when we can no longer say to our users, what is it you want? What we're really saying to them is, where should we start? And then over time, things may change. We may change direction as we go. In fact, we almost certainly will. Who here has started work on a big program and 3 years later ended up roughly where they thought they would be? A few, yeah? But it's not that common, is it? You end up somewhere great, hopefully, but not necessarily where you thought you would be. This means that if we view architecture in any sense as a upfront decision-making activity, unfortunately, it's probably kind of doomed. There's a lot less value in making decisions early rather than later, because things are going to change. So we're just going to end up doing things multiple times. And then obviously the challenge is, well, that's fine, we just won't do architecture anymore. And that's where I stop and go, just a moment. Architecture work, whether or not you have people called architect, is really important. And there's a couple of reasons for that, and they're quite fundamental, and they're not going to go away with large language models and AI, as Simon was pointing out. There are some fundamental decisions we need to be making. Firstly, we need to achieve the quality attributes in the system. Security, scalability, performance, resilience, all those things. Those are very hard for individual empowered teams to do by themselves because they're inherently systemic qualities. Who here works in security? You ever had a problem with one team doing their own security thing? You know where that ends. It's an insecure system. The second thing is many people, we tend to call them stakeholders because of the business jargon, but many people care about our system. Some care passionately and want us to be successful. Some care equally passionately and would rather we just went away. Typically people in risk, compliance, audit, those kind of functions. But all of these people have legitimate concerns about our system. But I've repeatedly found, if you ask the individual delivery teams to go away and talk to multiple stakeholders and figure out what the right answer is, that's just not what they're good at. It breaks their flow. They often haven't got the right skills. And if you have multiple teams doing it, it confuses the stakeholders. So there is some need for centralized coordination between multiple stakeholders and teams. And the third thing is we are constantly making complicated trade-offs. Every decision we make has positive and negative qualities. Those are inherently trade-offs. And many of these trade-offs, again, have systemic implications. What we're really doing in all of this is we're resolving cross-cutting concerns. There are things There are problems, concepts, principles that are inherently at system level. And to me, addressing those, that is architecture. There are lots of techniques, lots of philosophies, lots of frameworks, but fundamentally, that's what they're all trying to do. It's to resolve the cross-cutting concerns in a system in the most optimal way possible. So what this means is architecture needs to be more continuous. Some people wrote a book back, 2005, and it was revised a few years later with this graph in it, which we look at it today, and it's almost laughable. They say the architecture work sort of peaks at the beginning, through the middle it's not so much, and at the end it peaks again. And I can laugh at this graph, same way Simon Wardley can laugh at the CEO. It's my graph. Nick Rosansky and I drew that graph in 2005, because that was sincerely our experience over the previous 10 years. Clearly, where we need to get to is the graph on the right. Architecture needs to be happening all the way through the delivery process, because we're continually learning and things are changing around us all the time. So all of this effort that we might put in, that didn't work, never mind. All that effort we might put in at that end, that's actually what I meant to do, won't be very valuable later on. So that's the backdrop. Continuous architecture is a philosophy, as much as anything else, about how you might organize architecture work in a world where you don't know much at the beginning. It's now 10 years old, nearly. Two engineers, Murat Erder and Pierre Pura, who both worked for large companies, both one in insurance, one in finance, came up with these ideas because they saw their organizations adopting agility, DevOps, cloud, all of these things that generate change, and a lot of people trying to do good architecture work and really struggling. So they came up with a few principles to try and guide people in their organizations, and that became the first book called Continuous Architecture. And the first principle now, it's entirely obvious. Architect products don't organize your work as a series of projects. Isn't that obvious? Think back to 2011. Was it obvious then? I would suspect not. Certainly the organizations I was in 2011 were entirely oriented around projects, even if many of the delivery teams were fighting to try and be recognized as product teams. Second principle is, one we mentioned earlier, focus on the quality attributes. To a large extent, the functions will take care of themselves. High-performing delivery teams with good product owners are very good at getting the domain problem solved. Well, as we've said, because they're systemic problems, they often find it really quite difficult to get the quality attributes fixed. Third principle is delay design decisions as long as possible. To an Agile audience, I don't need to explain it. We learn as we go, things change all the time. The later we can make a decision, the better. But again, especially in larger organizations, especially large product organizations that I've been in, there was an addiction to making decisions early. The reason was it was thought that it gave stability and it managed risk. What it actually did, of course, was stacked up risk, because we didn't know enough to make good decisions very early. Fourth principle is architect assuming you'll have to change it. Actually, even today, when I see people quite new to software design and architecture thinking about their design, it's quite rare that I find them sitting thinking, right, what are the dimensions through this is going to change in the future? They're normally thinking, how does it need to work today? It's just they don't add the today at the end of the sentence. But implicitly, they're really thinking, how does it need to work today? The point that we're trying to get across here was that if you build your system out of smaller pieces, it's probably going to be easier to change. I'd probably, in fact, say, think about the granularity of your pieces with regards to the kind of change you need to do. Obviously, again, today, things like function as a service, kind of microservices, have really driven this into the mainstream. Principle 5 is to architect for build, test, deploy, and operate. How many of you work with designers in your organization who do not think very much about how to test what they're designing? I see this quite commonly. It's not their bad designs. They're good designs. They are robust and functional and secure and scalable. And then you say to them, how would you test the scalability? And they go, oh, that's quite difficult. And you go, exactly, that's quite difficult. So we won't know that it's scalable because as Simon put it, it's an article of faith it's going to be scalable. If we can't test that, that's really difficult. So making sure, if we're going to, and the real point behind this was, if we're going to move fast and deliver software all the time in small increments, we better be very good at building it reliably. We better have extremely fast and extremely good test validation. We need to deploy it really reliably, and we need to be able to operate it and learn from it in the operational environment really well. And if we don't build that into the system, it all causes loads of pain later. And the sixth principle, excuse me, we don't talk much about now, but it's remember that the organization of your teams and the organization of your software have a direct influence on each other. And these days, honestly, we tend to point towards team topologies for that. There's a little bit in the first book, which I wasn't involved in, but there are people who know much more about management and organization than the three of us do, but we've seen it again and again. If you structure the teams in a different way to the software, you know what happens. Lots of communication problems, and your architecture just gets broken over time. So in terms of how does this affect what architecture work looks like? Well, we used to, of course, try and define very comprehensive models. We used to do lots of upfront thinking about structure. Actually, where we got to is there's three things we think are really valuable for architects to continue producing as their artifacts. One is styles and patterns. We do need to agree what the fundamental organization of the system is. Is it event-driven? Is it client-server? Is it Blackboard? Is it repository? Those styles. And of course, most systems are a combination. But which styles are we using? What are they used for? And where are they used? That's a useful thing to define really clearly. Of course, you have to define something at the beginning. You may evolve it. But at any point in time, you know what your styles are. And there will be problems that you want to solve the same way right across all of your teams. For me, my favorites are logging and monitoring. If you have 8 teams and you don't have patterns for logging and monitoring, how many approaches to logging and monitoring will you get? Exactly, more than 8. Anything more than 8 is fine, but at least more than 8. And 16, that's probably a guess based on painful experience, I would guess. So those would be obvious things to put into patterns. But there are many things in your systems. You know your domains really well. There are some things you know you need to do the same way everywhere. In a bank, for example, you need to represent money in the same way everywhere, right? Because otherwise, if money is represented differently, it causes immense pain later. We want to empower teams to make good decisions. We do not want to centralize decision-making. However, we need to give people context to make good decisions, and that's what principles do. So we need as a team to decide, and someone needs to lead this, we need to decide what are the principles that guide our design decisions. And we need to make sure that they're somewhere that, one, everyone understands them, and everyone can get to them. I'll talk a bit about principles later. And finally, if we're not going to have comprehensive models, we'd better be very clear what the decisions probably hidden in the code base are. I actually agree with Simon in the sense that architecture is largely in our heads. The code is the reality. Yep, I agree with that. It's actually the same in the built environment. If you look at architectural sketches and the building, the architectural sketches are how we think we will experience the building. They're not the concrete that gets poured. I'll stop using that analogy there because I think actually the analogy between those environments is a bit flawed. But I think it works for that small bit. So we need to understand what decisions we made and why we made them. So that when something goes wrong and somebody says, why on earth are we using a document database? It doesn't become a debate and everyone dredging through their memories. You know why we made the decision. And actually, when that was made, that was quite a good decision. We can see that now. But now we need to change it. And we know when we changed it. And what we're trying to get there, skipping forward again. What we need to get to is that we get to an evolving shared design. It's not, by the way, that we have no models. It's not that we have no performance models. It's not that we don't create any other architectural artifacts. We create what's useful. But the things that we think are always going to be useful are styles and patterns, principles and decisions. But we want the team to feel the ownership of these, not that some people sitting in the corner own them. Same as testing. Testers, I always say, are there to make sure good testing is done, not do all the testing. Architects are there to make sure good architecture is done, not do all the architecture. So the practices, which we have repeatedly found across teams are useful, are provide leadership, particularly technical leadership, focus on the quality attributes. This is becoming a theme, isn't it? I'm very keen on quality attributes. Drive, don't necessarily make, the architectural decisions. Manage technical debt really intentionally, because otherwise, we end up not being able to change the system. And implement feedback loops, because if we don't implement feedback loops, the benefit of this continuous approach is largely lost. So that's what we're going to talk about now, is what are these practices? Turning to the first one, which is provide technical leadership. I'm not talking, so the thing that really annoys me today is everyone who is somehow senior, even CEOs, are now called leaders. You can tell the difference between a leader and a manager. A manager's got direct power. They can fire people, raise and lower their salary, or do other positive and negative things to them. That's how they get people to do stuff. A leader is someone who can influence and drive behavior without having that direct power. Just think about your own executive team. If you took all the power away, would they still have the same degree of influence? If they are, they're great leaders, as well as great managers. Most of us in this room, I suspect, are on technical career paths. Although we may have some fancy title or highfalutin grade, we actually can't really tell anyone what to do. We need to lead them. And the key tool that I've found repeatedly in teams, the way to do this is to form a technical leadership group of the people who probably often self-select to want to be part of the architecture work. They're often not the most senior. They may not even be the most experienced. They may be relatively junior, but they have an affinity and an enthusiasm for this cross-cutting work at system level. You gather those people together, and you lead that group, and then they lead for you in the wider group. The key thing about the technical leadership is you are there to resolve technical concerns. So what are these architecture principles? A team might think about this themselves and get to a really good set. That's quite rare in my experience. Someone needs to drive that. Sometimes we have a difficult decision to make. And what happens when there's a difficult decision to make? No one wants to make a decision. So we just muddle through with like 2 of something or 3 of something, or really not resolving it. We just hope it'll come right. That's where leadership comes in. You need to decide, you need to be honest. There is no good option. Which is the least worst option that we should select from that list? Another example would be, what do we really need to do now for under time pressure? What can we defer? Which, of course, directly feeds into technical debt. And the overarching thing that I always feel that we're trying to do is we're trying to drive the team towards technical excellence. Hopefully they want to go there, but we need to be pointing out the long-term consequences of decisions. Yes, we could not test this bit properly now. The implications of that are the following. Are we all comfortable with that, especially senior people? You can be the conscience of the team because you have the status and the experience to be that. And a key side effect of this is, unfortunately, we often have to reflect the technical view of the team upwards, and sometimes protect the team from the consequences of speaking truth unto power. But that's all part of leadership. I think it's a really important part of technical architecture. The second practice is focusing on quality attributes. I'm not going to explain quality attributes. This is a room full of architects. But as you know, they're the cross-cutting concerns that need system-level attention. And they tend to be things like security, scalability, performance. The problem we tend to have is that most product owners are not gold on quality attributes. They're gold, directly or indirectly, on features. It might be revenue, but they believe features will drive revenue. It's quite rare that you meet a product owner that says, yeah, could we just stop and get the security right? Because that's really going to drive my revenue. Does anyone here have a product owner like that, who actually thinks about quality attributes on an active basis? I've got one nod, maybe? Oh, that's 4 hands. That is the most I've ever had. That must be a thing in Berlin. It really must. I've asked that question in Cluj in Romania, full of software engineering excellence. 1 hand went up. And everyone looked at them and went, no. And they went, no, really. I'm not telling you who they are. They're the best product owner I've ever worked with. They actually think about quality attributes. So that's the problem, is that they're very focused on features for good reasons, because that's what they're measured on. Be careful what you wish for. So we've got to find a way of explaining to them what will happen if they don't think about quality attributes? And for me, the key tool is scenarios. Think of them as structured stories. You've probably all come across them. You explain what the stimulus to the system would be. Massive load appears on Black Friday. What will happen? How the system should behave? What will happen if the system doesn't do that? And then spell that out typically in business terms, which of course requires a bit of perspective and a bit of cooperation often with the product owner. The problem, of course, is there's always more to do with quality attributes than we'll ever have time to do. So a really important part of the role is helping the product owner to work out what's the most important thing. Where should you be investing? Unfortunately, here, quite often, your Wardley map's not necessarily going to help because these things may not be to do with maturity of the market. And the problem we often have is you need to get this stuff into the backlog and worked on. So you could do a whole talk on that, really, as techniques for that. But I'm sure you've all got your special tricks. But of course, a strong relationship with the product owner is a really good way to do that. So the way I visualize this is quality attributes are partly businessy, that's blue, and partly technical, that's orange. And so what we need to do is get them described as a business concern, as in, we have a scalability problem, that's your problem. Because otherwise, if you start talking about scalability, performance, security, most product owners go, oh yeah, that tech stuff, that's your problem, right? No. It's your problem because it's your system. We are simply facilitating the build of the system. And the way that I get the business concern, I tell them stories. Always doom-laden stories of things that will go wrong. Obviously, I don't tell them good stories, otherwise that doesn't achieve anything. And so once they have become a business concern, that's when we can get the authority to give them some technical attention. And that's when we get into the technical side of it is we need to be able to measure them so we know if we're headed in the right direction and how good or bad our architectural tactics. The tactics, as you know, they're the techniques we use for achieving one or more quality properties, quality attributes. That's my mental model of how I do that. The third practice is driving architectural decisions. So if we're going to dial down on comprehensive models, which I think is exactly the right thing to do, because they're always out of date, we need to dial up on architectural knowledge and decisions, and one of the way we do that. So how we make them, validate them, manage and implement decisions is really important. The technical leadership group are your friends here, because there's too many decisions for any person who's called architect, or even just the principal engineers. There's always too many decisions to make. So using that wider technical leadership group is a really good group of people to use to own decisions, do the research, validate stuff, sell decisions to the rest of the team. One of the problems, though, is how do we capture decisions? I don't know what you're doing. I've seen lots of ways of doing it. I can immediately state my bias. The worst way of doing this, and I apologize if this is what you're doing, the worst way of doing this is put them in a Word document and keep them in SharePoint. That means they are write-only. They will never be read. In fact, they may not even be written after a while because people get so annoyed with SharePoint. But the two ways that I've seen that are quite successful, though neither is perfect, is so firstly using ADRs. That's not exactly rocket science, that's just structuring your decision. We've been doing that for decades. But keep them in Git, checked in as, broadly text files, or to keep them on a wiki, such as Confluence. I know Atlassian's not everyone's favorite company at the moment, but a wiki of some form, and probably linking between the two. They both have their strengths and weaknesses. The problem with the stuff in Git, as you're probably aware, is you need to think about how you'll visualize it and access it, because especially if you're in a bit of the code base that you don't normally work in, or you want to get a slightly richer view than just a set of text files, you're going to have something that does that for you. So you have to download or build that, add that in. Wiki, obvious problem is that it's disconnected from the code. So you're going, well, as of this commit, which set of decisions were active at the time? And you need to find a way of resolving that. Maybe not for every commit, but for major commit points. The other thing that I've spent lots of time with our customers looking at is how you curate decisions over time. You need to make sure that decisions are still, one, correct, and two, captured correctly. What tends to happen is people generally think, design decisions in ADRs, that's a good idea. I'll go do that. And you end up quite quickly with sort of 80 decisions all in a big flat space, be that a single directory or be that a single wiki page, which just goes on forever. So you have to start thinking about what is the structure of these decisions, how do they relate to each other? There's lots of ways of doing that. And then how are we going to make sure that the key ones are understood widely, the detailed ones are understood by the smaller number of people who need to understand them? How do we make sure that they're coherent, congruent with each other? And how do we make sure that over time they stay valid and correct? Again, I think that's a whole talk. I'm not really going to go into that. I'll just say it's something that it's worth thinking about fairly early, because we've had quite a lot of companies, clients of ours, who've started doing this, often at our suggestion, and they've got to the 80 or 100 before they've started thinking about how are we going to manage this set of decisions. And at that point, it's quite hard. It's much better once it's taking off and you've got 10 or 12 to go, right, suppose you have 10 times more, is this still going to be useful? The answer is probably no, so what do we do? And there's a number of ways we could do that. The other thing about decisions is make sure that they still work with the principles. If you're making lots of decisions that violate your principles, either you're ignoring your principles or the principles are wrong. They can be a very useful feedback loop back to the principles. Fourth practice is managing technical debt. Again, some of you here have probably given talks on technical debt. You can talk for hours about technical debt. The problem with it is it's a very nebulous concept. It's very context specific, as I'm sure you're aware. When you look at something, if somebody hands you a single source file and says, is there any technical debt there? It's quite hard to judge, because one person's debt is another person's simple, sensible thing. So suppose you've got validation code, and you have a single class with lots of validation code hard-coded into it, neat and tidy, well-tested. Is that technical debt? Because they should have used like a chain of responsibility of validators? Or is it the simplest thing possible? It's completely context-specific. The other thing is, does technical debt matter? You meet people with very different views on this. I've had a number of interesting conversations about that. But to me, the point is, technical debt matters when it stops us doing something. If it's now too expensive to make a change, if it's now too risky, expensive to update a piece of technology, if the team can't react fast enough to the speed the business think they need to, whatever your business is, that they need to, if we're just too inefficient to be seen as providing good return on investment, that's a problem. And bear in mind that technical debt is not just caused by people not writing good unit tests. The environment naturally creates technical debt. Context changes all the time. Simon mentioned this in the first talk. It's the only constant is change idea. Just changing context. Think about libraries you put in a few years ago which now look like technical debt. There is, of course, development practice. That definitely can create technical debt. But so can the team structure. Sometimes we just get the wrong team structure for the software. As I said earlier, we don't notice that the two aren't very lined up. We end up with loads of technical debt because code gets duplicated. That's just because that's the structure of the people. Ways you can deal with it, I think there are three main strategies. I've used all these over the years in different environments. Just in time, so you let it build, but you're constantly thinking, oh, that's got to a certain level, let's proactively pay that back. There's little and often, that's where you pre-negotiate with the business. 15%, 20% of our time is always going to be, don't call it technical debt, call it technical improvement, or business value creation. And you're trying to keep it low the whole time. And then there's kind of effectively crisis management. Which one is most common? Any guesses? Yeah, I think it's crisis management, which I've called politely cleanup. And that's where you let it get to a critical point and you just have to stop. I've been involved in it, especially in banking. You will not be surprised to hear a number of project teams who got to this point, and I was actually brought in as the architect to sort a technical debt problem out. We just stopped doing new stuff, in effect, other than emergencies. My last practice is implement feedback loops. These are important, and I don't find many people discussing feedback loops in architecture. It's often taken, I think, as implicit, but I think they need to be thought about a bit more explicitly. we normally think of the development cycle as team producing great stuff, checking into a repo. Hopefully, they're informed and guided by architectural decisions and knowledge, and you've got a constant architecture cycle going, keeping all that up to date. Down a delivery pipeline, into production, bang, everything's great. Or is it? How do we know? Well, we of course have some operational monitoring to tell us if the system's up, but that's not really the most sophisticated feedback loop. There's two sorts of things we need to be measuring. There's the internal stuff largely, which is artifact measurements. There's stuff going down a pipeline, so we need to apply measurements to that to know what is the quality, and of course quality is extremely context specific, but in fact I'd say what are the characteristics of what's going down the delivery pipeline. And then there's operational measurements. And for all of these, you can consider, should I be looking at a trend, or am I actually worried about a limit? Is it if I break a limit, I immediately have to stop and fix it? Or is it more, I have a trend, and I'd like to understand the trend, and then that will allow me to take action? I describe them as an architectural reality check. You know you're doing great architecture work if your key measures of your artifacts and your operation are trending in the right direction. They typically measure quality attributes, but there are functional things, often business measures, time of engagement, time to sign up, transactions processed, dollar amount, all of those things are valuable. And they can be the internal and external measures. Key thing is, especially for architects who feel that they can't necessarily do production coding anymore, this becomes a massively complicated hobby project very, very quickly, because it's really very interesting. My advice, having made that mistake multiple times, is start small and simple and keep challenging yourself. Do I really need this to be dynamic, automated, and scalable? Maybe, but maybe that just looks like fun. So, to conclude, we used to think about, this is my archetypal architect I use in all my talks. This is Adriana the architect. We used to think about Adriana as largely spreading wisdom to the teams and doing a lot of that front-loaded. And we need to completely flip that on its head to put Adriana in the middle of everything, with the teams doing a lot of the architecture work, guided by her years of experience and all of the knowledge she has from her deep technical qualifications. Because what's happened is that Agile has given us continuous evolution, or at least has attempted to, and that's great. That's exactly what we need. And so whether we're aware of it or not, we are now in a continuous software engineering environment. And that means architecture that is front-loaded is almost certainly, not always, but in most cases, is less valuable. And that led to a number of people saying, well, architecture has to become continuous. And the practices that we found to be really useful when an architect is trying to work in this style is to focus on technical leadership, make sure that the quality attributes are being addressed, actively manage technical debt, treat decisions as a first-class artifact and manage them very intentionally, democratizing that through your team, and build feedback loops, because without feedback loops, all this ability to deliver quickly is partly wasted, because we don't know if the changes we're making are heading us in the right direction or not from an architectural perspective, rather than just from a features perspective. I'm just about out of time, so there are various books that are either about continuous architecture or very congruent with it. They're kind of similar. And funnily enough, while Murat and Pierre were thinking up this idea, a team in France, sponsored by the Michelin Corporation, were thinking up exactly the same ideas with slightly different words, which is why I put their website up as well. That's the green one. So you've got continuousarchitecture.info and continuous-architecture.com. The second one is the French team, who are fascinating. We have quite a good but very arm's length relationship with them. But to me, it was a huge validation of Murat and Pierre's ideas that some people right kind of across an ocean had exactly the same problems and solved them in roughly the same ways, which is why I think these ideas really have legs. Those are the books that were on the slides. And other than that, thank you for your attention. I'd be really happy to take any questions.
Wow, thank you so much. Let's start with the first question, the most upvoted one as of now, about those last-minute architectural changes, how to determine when is the last responsible moment instead of a little bit too late?
That's such a good question. So yes, when is the last responsible moment, or as opposed to the moment that is the moment we're at now, which is just too late? You may know someone called Sandro Mancuso. It's very well known in Europe as all over the world, but especially in Europe, software craftsmanship. Sandro and I worked in a big bank together for a while, and to start with, we had quite a spiky relationship because I was very architecture, he was very craftsman, and actually we're good friends now, and we, while working together, got to understand the other perspective much better. This was one of the things we continually talked about. Sandra would say, last responsible moment, and I'd say, no, just too late. And actually, I think, to be honest, if we had an answer to that, both of us would have set up some company to sell it as magic secret sauce and would be retired by now. I think what you need to constantly be validating is, if we don't make this decision now, there's the cost of delay idea. If we don't make this decision now, what would be the costs if we had to make it or change it in certain time horizons? But I think this is where your skill and experience, that's why experienced people are architects. I'm afraid, I think it's there's management theory, but I've not found it to be very helpful. I actually have tended to find expert judgment in a team of people who debate it with each other is actually the most effective way to work out when it's going to be just too late. Your bigger problem, I have found, though, is that when you think you need to make the decision in a large organization, you then get the problem that getting the decision ratified and actually moving then pushes you across the just too late boundary. And that's something that's very specific to your context, but that caught me out and caught Sandro out a number of times in a big bank, and that's the other aspect to that to think about.
Thank you very much. The next question is about fitness functions and how far you would recommend them as a means of ensuring that the architectural ideas are really implemented in the code itself.
Oh, that's a hard question. And Neil Ford and Mark Richards are not here. Sorry, not Mark. Pat Qua and the others are not here. Conceptually, I think fitness functions is a brilliant idea. I was really, really impressed when I read the first evolutionary architecture book because it was such a simple idea and yet very elegant, and yet I'd never thought of it. I thought, well, why didn't I think of that? It's a really good idea. The slight qualifier I have is I think you can wrap especially automated or semi-automated fitness functions around certain things quite easily, and the return on investment is obvious, and you should definitely do it. I think there are other things that conceptually you could put fitness functions around, but are actually quite difficult to do reliably and cost-effectively. And I've talked to both speakers at other conferences, architects in my organization, client architects, and I've had quite similar views, which is, yeah, we did try a fitness function on that. It was very hard to make it reliable, and we ended up burning a lot of cycles, and actually we'd rethink how we did that. So I definitely think it's a good idea. I think what you need to do is do a really deep spike to work out, can we build a reliable one in reasonable time?
Makes a lot of sense to me. Thank you so much. We still do have many more questions, but unfortunately not more time here. But feel free to
grab me at the break.
Owen in the break, which starts now. Once again, thank you so much for the talk.
Thank you.